What's up developers, welcome back to the channel. If you have been following along with our NestJS series, you know we just built an incredible authentication system with JWT tokens, user registration, and bulletproof security. But today, we are taking it to the next level with one of the most requested features in modern web development, file upload. And this isn't just any basic file upload tutorial, we are building a complete music platform that handles MP3 uploads, metadata extraction, cover art, and so much more. In this episode, we are laying the foundation for our music platform. Here's exactly what we'll accomplish. Secure MP3 only uploads with bulletproof validation, 10 megabyte file size limits for optimal performance, smart file organizations with unique naming strategies, complete database integration with rich metadata storage, cover art upload system for beautiful music libraries, user isolation, which means everyone only sees their own files, and automatic cleanup when things go wrong. This foundation will support all the advanced features we will add in the future parts. Streaming, sharing, playlists, private and public songs, and more. Now, if you're just joining us, don't worry, this is part 1 of our file upload series, but it builds on our authentication system from the previous episode. I'm gonna link that video in the description. You'll want to watch it first to get the full context out of this course. And speaking of context, this is going to be a multi-part series. Today we built the foundation, and in the next video we'll add music streaming, search functionality, and public sharing features. So make sure to subscribe and hit that notification bell. Alright, enough talking, let's build something amazing. Grab your favorite beverage, open up your IDE, and let's turn your NestJS app into a music platform. Let's install the necessary packages for the file upload functionality. npm install add nestjs /platform-express multer add types/multer. NestJS Platform Express is the built-in Express integration for NestJS. Multer is the most popular Node.JS middleware for handling multi-part form data. And add types multer is TypeScript definitions for the type safety of Multer library. Let's create our module structure. First of all, in src, I'm going to create a new music directory. Then inside music, I have my DTO directory. I have entities. Finally, outside of the src, I have my upload directory. And when you do that, it's time to create our database schema design. Let's start with database schema. Our music file entity will store all the metadata for a music. So inside music DTO entities, let's create a file called music entity.ts. I'm going to create a new entity called music files. Then let's say export class music file. First of all, primary generated column UUID, which is ID, which is a string, column file name, which is a string as well, column, which is original name, which is a string again. Then we're gonna have a bunch of nullable columns. First one is gonna be title, which is a string. Let's make a bunch of copies out of it. Next one is gonna be artist, album, year. Finally, we have genre. Then we have a column of decimal. Precision is gonna be 10. Scale is gonna be 2. And it's gonna be nullable as well. It's called duration, which is a number. And this number is gonna be in seconds. Then we have another column, which is gonna be size, which is a number. Our next column is gonna be format, which is a string. Let's make a default value for this, which is gonna be MP3. Our next column is gonna be nullable again. Bitrate, which is a number. There is another one called sample rate, which is a number again. We have another column which is gonna be file path, which is a string, another nullable column, which is gonna be cover art string. We have another column, user ID, which is a string. Finally, we have create date column and update date column. We have a many to one relationship for this entity, many to one. So this entity is gonna have a many to one relationship with user entity, which we are taking user.id from it. And on delete, we're gonna use cascade. We're gonna join this column with the name of user ID, and we have this user. This entity captures everything we need. File information like name, size, format, path, music metadata like title, artist, album, genre, year. We have audio properties like duration, bitrate, and sample rate. We have user relationships. Each file belongs to a specific user, and each user can have multiple files. And finally, we have our timestamps. Next thing we're gonna do is to create our DTOs. So let's create a DTO called upload music.dto.ts. So let's say export class upload music DTO, and here I'm gonna use, first of all, is optional, is string, and max length of, let's say, 100. I'm gonna say title, which is a string. I'm gonna repeat the same thing for our next property, and it's gonna be artist. We then have our album. Finally, we have our genre. And finally, we have year, which is a number. And let's just say is optional. There we go. So our next DTO is gonna be music response DTO.ts. Let's say export class music response DTO. And here I'm going to use expose. First of all, ID. Let's make a bunch of copies out of it. The next thing is going to be file name, original name, title, artist, album, genre, duration, which by the way is a number. Let's add a transform and take the value of it and just return parse float of value. Then we have year, which is a number. Okay, we need more copies. We have format. We have bitrate, which is a number. We have sample rate, which is a number again. Cover art, user ID. Now we've got size as well here, which is a number. But something we're gonna do is that we're gonna convert bytes to megabytes with 2 decimal places. So I'm gonna use transform, take the value out of it. Let's say return parse float. There we go. And finally, we have created that and updated that. And let's not forget to create a constructor, partial music response DTO object that assign this to partial. Nice. Our DTOs are done as well. Now let's implement the Multer configuration, the heart of our file upload system. This is where we define validation, storage, and file naming. So let's create a new folder called config. Inside here, I'm going to create a new file called multer.config.ts. export const mp3 file filter. So we're getting request, file, and callback. So first two things you need to check is to check file extension, like it's mp3, mp4, m4a, or etc. Then we're going to check for MIME type, and finally we have our callback. A MIME type is a two-part identifier, such as image/JPEG or text/HTML. This actually classifies the format and type of the content in an internet message or in a file that we're receiving, right? It's basically the content type in requests. So let's say if file.originalName does not match mp3, then go ahead and return callback, new, let's say bad request exception. Let's say only mp3 files are allowed. Notice that the next argument we're passing to our callback is false. Now let's check the MIME type. If file.MIME type is not audio.mpeg and file.MIME type is not audio/mp3, return same callback with same messages. And finally, if everything is okay, go ahead and use this callback with null and true. Now next thing we're gonna do is to create a function for image filter for cover art, right? So export const image file filter. We have the same thing as we had above. Let's say if file.originalName basically does not match, yep, exactly what these formats, return callback, new, bad request exception, only image files are allowed. Then let's check for MIME type. If file.MIME type starts with image, actually does not start with image, return callback, new, bad request exception, only images are allowed, false. Finally, callback, null, and true. Next thing we're gonna do is storage configuration for music files. After that, we basically have storage configuration for cover art, and then we have file size limit. So let's say export const music storage, disk storage from Multer. Then we're passing a bunch of stuff. First one is destination. So let's say join process.cwd uploads music. So for file name, we're gonna do something cool. We have access to request, file, and callback. Now first, I'm gonna get user ID from request. So let's say const user ID is request.user.id. Then let's go ahead and create some unique file name for it. We're gonna follow this pattern. So user ID, timestamp, original name.mp3. So timestamp is gonna be date.now. Original name is gonna be file.originalName.replace. So in replace, we are replacing spaces with underscores, right? So let's say replace spaces with underscores. Then we have this sanitized name, which its purpose is to remove special characters. So let's say original name dot replace. There we go. Finally, file name is gonna be this. And let's say callback null file name. So for storage configuration for cover art, we have basically the same thing. Let's say cover art storage. In here, let's add cover. For file name, we have user ID. We have timestamp. Let's get rid of this sanitized name and original name. So we have timestamp, user ID. Let's add a cover underscore user ID timestamp. Let's get rid of this sanitized name. But for extension, let's create a variable called extension. I'm going to use something called ext name, which is coming from path package, file.original name. And let's use extension here. Now the last thing is an object called file size limit. For music, it's gonna be 10 megabytes. And for cover art, let's go with 5 megabytes. So let's break down this configuration together. We check both file extensions and MIME type for security when the user tries to upload any cover art or any music. This basically prevents users from uploading malicious files with fake extensions. We have a great file naming strategy. Format is like this for MP3 files, and for images and cover arts, we have this format as well. Finally, our storage strategy, we use disk storage for local file system storage. We separate folders for music files and cover arts, and we have absolute path using process.cwd for reliability. Now let's implement our service layer with robust error handling. Let's create a new file, music.service.ts. First of all, injectable, export class music service. We have our constructor here. Inside constructor, we have inject repository from TypeORM. We're gonna pass MusicFile entity, private read-only MusicFile repository, which is of type repository MusicFile. Now we have a bunch of functions we need to implement. First of all, upload music. Next one is upload cover art. Next one is get user music. Then we have get music by ID. Finally, we have delete music. And the last one is a private function, which is extract title from file name. So upload music takes a file which is of type express.multer.file. We have upload music DTO, which is of type upload music DTO. And we have a user, which is of type user entity. First of all, we're going to validate file exists. So if no file, throw new bad request exception. Let's say no file uploaded. Then we're going to validate file was actually saved to disk. So let's say if I'm going to use fs exists sync file.path, then throw new bad request exception, file not found. Let's import fs as well. Import star as fs from. When we're done with our validations, we're going to do a bunch of more steps in a try catch block. So first, we're going to create music file record only after confirming file uploaded successfully, right? So let's say MusicFile, this.musicfile repository dot create. I'm gonna pass a bunch of stuff. First, file name is file.filename. We have original name, which is file.originalName. For title, I'm gonna go with upload music DTO.title. So if it doesn't exist, this.extract title from file name, file.filename. There we go. So the next thing is artist, upload music DTO.artist, or let's say unknown artist. For album, we have same thing. For genre, we have exactly same thing. Now for year, we have upload music DTO.year, or we're gonna go with new date dot get full year. Size is gonna be file.size. Format is gonna be MP3. File path is gonna be file.path. User is gonna be user, and user ID is gonna be user.id. So something I forgot is that we need to make year number in our entity. Now let's go ahead and implement this function. Let's say it takes a file name, which is a string. We're gonna say name without ext, which stands for extension, path dot parse file name dot name. Let's import path right away. Import star as path from path. Now let's create a clean name with ext, replace. We have created a clean name. And finally, let's capitalize first letter of each word. So let's say return clean name dot split by this dot map word. We take each word and we return its first character dot to uppercase plus word dot slice dot to lowercase. Finally, we're gonna use join, and that's it. Now back in upload music function, let's say saved music, this dot music file repository that save music file, then return new music response DTO saved music. There we go. Now there is an important note here. If database save fails, we need to clean up the uploaded file. So inside catch, we're gonna say if file and fs.exists sync, then we're gonna pass file.path. In this case, we're gonna clean up the uploaded file. So let's say fs.unlink sync file.path. Finally, throw error. Now for upload cover art, we first gonna get a music ID, which is a string. We get the file express.multer.file, and we get the user. So first of all, we're gonna validate file exists and was saved successfully. So let's say if no file or fs that does not exist sync of file.path, we're gonna throw new bad request exception. So let's say cover art file upload failed. Then we're gonna find the music. So await this dot music file repository dot find one, where ID is music ID and user ID is user.id. If no music is found, first of all, cleanup file if it's uploaded. So let's repeat this step. And finally, throw new not found exception, MusicFile not found. Now inside the try catch block, we're gonna first remove old cover art if it exists. So if music.coverArt and fs.exists sync music.coverArt, go ahead and remove it. Then update music with new cover art. So music.coverArt is file.path. Let's say updated music. Oops. Updated music. This.music repository that save music, and then return music response DTO updated music. In catch, we have the same step that we had in upload music. There we go. Our next function is get user music. So in here, we're getting a user ID of string. We're getting a page, which is a number, and a limit, which is a number as well. But we need to provide some default values if the client didn't send these values to us. So for the page, I'm gonna go with number 1, and for the number, let's say 10. These are some properties that we need to handle pagination in our responses. If you don't know anything about pagination, don't worry at all. It's something really easy and easy to follow and understand. So I'm going to provide some links in the description below. Make sure to check them out. So this function is going to return an interface. We have music, which is of type music response DTO. Actually an array of music response DTO. Then we have total, which is the number of musics that is being returned to client. And finally, total pages, which is a number. So let's say skip, which is page -1 multiplied by limit. This is the pagination thing that I've been talking about. Then we're going to say music total await this.music file repository find and count. And in here, first of all, I'm gonna pass in the user ID. Then I'm gonna say order is based on created at, and we're gonna pass in descending. And we're gonna pass in skip and limit as well. Now let's create our responses. So music DTOs, music.map. We're taking each music and we're creating a new DTO of response for that music. For total pages, we have math.sale, and we are going to do this division, total by limit, and finally we're returning music DTOs, total, and total pages. This function is so simple. We take an ID and a user ID, which is a string. We're returning a music response DTO, music file, await this.music file repository that find one. You know all these steps, where ID and user ID. So let's say if no music file, throw new not found exception, and let's just say music not found. Finally, return music response DTO of this music file. There we go. Now, as a practice to learn something from this course, go ahead and implement this delete music function. I'm going to copy and paste the implementation here, but feel free to pause the video and check if you can implement it. So now we are done with our service. There are some key features that we've been implementing on this service. First of all, we have data integrity. We only create database records after confirming the file was saved successfully. We have automatic cleanup. If any step fails, we clean up uploaded files to prevent orphaned data. We have smart defaults. What do I mean by that? Is that if users don't provide metadata, we extract a title from the file name. And finally, we have user isolation. Users can only access their own files through user ID validation. Perfect. Our next step is to create music.controller.ts, as you guessed. So I'm gonna pass in the controller music. We're gonna use guards. I'm gonna pass in the JWT guard that we created before. By the way, if you haven't watched the previous video, make sure to watch it and subscribe for the next part. Use interceptors, class serialize interceptor. We talked about this concept in the previous video, so make sure to check it out as well. And then let's export class music controller. Inside constructor, we have private read-only music service, which is of type music service that we just finished writing. Now our first method is going to be a post method, which is the upload. Now in here, I'm going to use an interceptor here, and I'm going to pass in the file interceptor from NestJS Platform Express. And in here, I'm going to pass in the music as the first parameter. Then the storage is going to be music storage, which is coming from our config. File filter, we have MP3 file filter. And finally, we have the limits as file size of file size limit dot music. Now let's create our actual function, upload music. So we have our uploaded file, which is coming from NestJS common. It's a great decorator that we can use. The file is of type express dot. The file is of type express dot multer dot file. In body, we are receiving uploaded music DTO, which is actually of type upload music DTO. And finally, we have access to our custom decorator that we created in the previous section of current user of type user. There we go. And we are returning a promise of music response DTO. So let's say return this .music service .upload music. Upload music. Then I'm going to pass file, upload music DTO, and user. Now our next API endpoint is going to be post/id/cover. So we again are going to use interceptors, and we're going to pass the same things here to our cover, but in here I'm going to pass cover. This storage is going to be cover art storage. This one is image file filter, and we have cover art as our limit. So let's say async upload cover art. We're getting our parameter, which is id, which is of type string. We have uploaded file, which is file, and which is of type express.multer.file. Then we're getting current user, which is user, and it's of type user. We're gonna return a promise of music response DTO again. Return this .music service .upload cover art. We're gonna pass in ID, file, and user. our next API endpoint is gonna be a get. So let's say get user music. We're receiving current user, which is of type user. Then we are receiving page from query decorator. Finally, we have our next one, which is limit, which is of type number, and its default value is going to be 10. We are receiving promise of music response DTO, but actually an array of music response DTO. So what's the difference between this query and param? As you can see, param is something like this, but query is like localhost 3000/music, and then in here we're receiving query parameters like so. These are gonna be called query parameters, those that are coming after this question mark. So as we have pagination here, we're receiving a total as well, a total page as well, and finally we're gonna have a current page as well. So these are gonna be called music, and we need to provide an object here. So let's say result await this dot music service dot get user music. As the first argument, we're passing ID, then page, then limit. Let's return result, which is coming from this music service get user music. So in result, we have music, total, and total page. We need to add the current page as well. So the current page is going to be page itself. Finally, we're having another get, which is called get music by ID. We have a parameter called ID, which is ID of the music, which is a string, and we have current user. We're returning a promise of music response DTO. So let's say return this music service dot get music by ID. We're gonna pass in ID of the music and ID of the user. Finally, we have this delete method, which is gonna be delete music. We're receiving a parameter of ID, current user. There we go. We have our user, our authenticated user. If so, then we're gonna return a promise of message, which is a string. So let's say await this dot music service dot delete music ID user dot ID, then return message music deleted successfully. So it's time to wire everything up together. So inside music.module.ts is being created. Add module. In here, I'm gonna pass a bunch of stuff to our module. First of all, inside imports, we have TypeORM module.for feature, and we're passing in an array of our entities here. Then we're gonna register our Multer module. So register. I'm gonna pass the dest, and I'm gonna use uploads here. After all of this, I have my controllers, which is the music controller. Finally, we have our providers, which I'm gonna pass our service to it. And finally, let's export our music service. Now let's export class music module. There we go. Our last step is to register our music module in app module. So nothing complicated. There we go. And we are done with our music module for now. Note that since we're using Docker, we need to set up volume mounting so uploaded files appear on our local machine. So inside our Docker Compose YAML file, inside our app service, let's add a volume here, /uploads/app/uploads. This line actually maps the containers /app/uploads to our local uploads folder. So we can see uploaded files immediately and they're being synced together. So don't forget to add this line. If you don't add this line to our Docker Compose YAML file, you're not going to be able to see our uploaded musics. Let's also add this uploads to our git ignore. Finally, let's rerun our app to see if there are any errors. Docker compose up --build. There we go. We have no errors. We have implemented the basic functionality of a Multer upload system, and we are good to go with the rest of the tutorial. And there we have it. We just built an incredibly robust file upload system for our music platform. So let's quickly recap what we accomplished. We had secure MP3 validation, smart file storage with unique naming using user ID and timestamps, complete database integration, cover art upload system, bulletproof error handling, and user isolation. And as you know the drill, I'm going to provide a test file which you can run the app and test your application using that test file. I have tested it. Everything works perfectly. We can upload MP3 files with metadata, add cover art, list our music library with pagination, and even handle edge cases like invalid file types and missing authentication. The HTTP requests we tested show that our API is robust, secure, and ready for real-world usage. Your users will have a smooth, reliable experience uploading their music. If this video helped you understand file uploads in NestJS, smash that like button. It really helps the channel grow, and definitely subscribe if you haven't already, because we are building something special with this series. Each episode builds on the last, and by the end you'll have a complete production-ready music platform. Drop a comment below and let me know if you have any question. What features do you want to see in the next part? Or you just have a simple feedback? All the code from today's episode is available in the GitHub repository. Link is in the description. You're also gonna find the HTTP test file that I was talking about, so you can test everything yourself. Thanks for coding along with me today, and I'll see you in the next episode where we are gonna make this music platform even more awesome. Until then, keep coding, keep learning, and keep building amazing things.